So for everyone that's just now joining, welcome. We're happy to have you here, and we're going to get started. I mean, it's right around the hour, so I'm going to hand it over to Jamie, and welcome, Jamie.
Oh, Rebecca, thank you. Appreciate you making this a part of Stormwater Awareness Week. We're happy to be here. I appreciate everybody that's able to get on this afternoon, and hopefully you'll find this informative. If you have questions along the way, please feel free to put those in the chat, and we'll either respond to them as we move along, or at the end we'll have some time as well. So my name's Jamie McCutcheon. I'm with Rymar Waterworks. Today we're going to talk about our topic is pond plus skimmer plus filter equals 90% TSS. So this is using skimmers for reduced maintenance and post-construction water quality. Also, just to help on the recording, I'm going to cut my video off, and I think that helps with the recorded there. So there. All right. Again, my name's Jamie McCutcheon. I am the founder of Rymar Waterworks. I'm a 92 grad of Clemson University and have spent about 30 years working as a civil engineer with a focus on private development, heavy influence on stormwater in that. I said in 2013, founded Rymar Waterworks, and I invented the Marley Float Skimmer. And I am a licensed engineer in South Carolina, North Carolina, and Georgia. So point of all that being, hopefully I can speak the lingo and provide some informative information for you today. So what we're going to talk about, we're going to understand the benefits of use of skimmers in permanent basins. Hopefully many of you are used to using these in construction settings and sediment basins. They've become quite popular and kind of the norm. We're going to talk about use in permanent basins. We're going to try to recognize some opportunities for retrofit of existing basins by adding skimmers to reduce maintenance and enhance water quality. And then we're going to introduce the new post-construction filter for water quality to achieve 90% TSS removal. I know that's all the goal we have is getting at least 80 to 85% TSS for most of our projects, and we'll show you how to do that with this new filter. So a little background information. Skimmers have been around for many years. They've been promoted for use in sediment basins during construction. That's probably been 20 to 25 years, depending on where you are in the country. I know some states are just now coming on with those, but like North Carolina, South Carolina have been around for quite a while. They meet the requirement for surface withdrawal from sediment basins. So most construction general permits have in there a provision to do dewatering from the surface of sediment basins, which drains the basin from the top down, and it releases the cleaner water from near the surface. Skimmers have been shown to greatly increase trapping efficiency of sediment basins. So it's typical to get over 90% trapping during construction with those very heavy sediment loads, which is better than what we used to do with perforated risers. So, since we're doing that in construction, it makes sense to consider those for post-construction as well. So there are a variety of skimmers out there. The Faircloth skimmer kind of started things, at least on the commercial side of it. The Rocean Supply ESC skimmer, Marley Float, IS. There's one called the Delaware skimmer that is designed for contractors to be able to make themselves as well. And there's probably a few others, but these are the ones that I'm familiar with. So skimmers float at the surface of the water and withdraw from the surface or near the surface to release the cleaner water at the top of the water column. So, the idea is that, as water comes into your sediment basin, we want to get the sediment to settle as best we can. And so the cleaner water is going to be near the surface of the basin. So the idea is you take that off first and give more time for mud to settle to trap as much sediment as you can. I already got one question in chat, and I'll probably try to answer these as we go along, but may save some to the end. So can these work for cold weather climates during the winter and freezing conditions? The answer is depends. If I'm in South Carolina, so yes, year round because we don't get. If you're in, a very northern area with maybe 6 inches to a foot of ice, then they're probably going to stop working depending when it gets really thick there. So you do have to be aware of that. If you're in a climate that does get, more than say 6 inches or a foot of ice during the winter. So this little quick video of a site actually in not too far from us. It's right against Lake Hartwell, South Carolina. So this is a sediment basin. You can see that basin was pretty muddy, but the discharge that's going out, it's actually relatively clean water. So, from the really muddy sediment basin that you saw there to that being released, just a good example of how effective skimmers can be in that during construction phase to release that cleaner water from the surface. So, basins rely upon the natural settling of sediment particles as they travel from the inlet to the outlet. So, you've got water coming in, you've got the sediment coming into the basin. So the idea here is that you want to get as much to settle as you can. So particle size is set particle settling is dependent upon the particle size and velocity of flow. So what we're going to try to do is we're going to try to slow things down to give it time to settle. And the heavy stuff's obviously going to settle out quicker, but the smaller particles are going to tend to make it all the way to the outlet structure. So it's important to slow the flow down and have sufficient travel distance for the particles to settle before reaching the outlet. So just a couple of graphic examples. So the general idea of what we're trying to accomplish here is get that mud, sediment particles down to the bottom, and then release cleaner water from the pond. So, often we work with dry detention basins. So your typical dry detention basin will look, maybe look like this one. It actually looks really good. It's got a good grass standing there. So obviously not getting a heavy sediment load anymore, but it is still getting some pollutant runoff even in fully stabilized conditions. And so the typical is to have some sort of a riser structure and then a low flow orifice, some sort of protection at the bottom to release the water. Typically also have some sort of sediment forebay to hopefully try to capture the larger particles so they don't spread out across the pond. So again, this is our typical dry basin. When construction's complete, you're going to remove the skimmer. You can install some sort of low flow orifice at the bottom of the riser to release that first flush. This is assuming that you're in an area that does water quality requirements, and you have that first flush is the traditional method to do water quality. And so this also often includes some sort of guard or filter to reduce clogging. So you want to try to protect that as best you can. But with this traditional design, what we're doing is we're relying on ponding and settlement to settle all the sediment particles to the bottom of the pond, but then we're discharging from the bottom of the pond where that sediment concentration is highest. So, the sediment's going to reach the outlet. The larger particles are going to settle, but smaller particles likely not. And so what we want to do with using the skimmer is use this natural settling and release the water off the surface sooner or first, and then retain as much of this sediment in the pond as possible, which is what the pond's there. So why would you consider withdrawal for permanent basins? So first thing is permanent basins rely upon settlement to capture pollutants. So our designs are typically based on a first flush volume that's going to be released over 24 to 48 hours to attempt to achieve sufficient settlement time. The low flow water quality orifices often need to be 3 inches or less, depending on the size of your site, and they're prone to clogging. So they need some sort of anti-clog feature in them, whether it's a stone filter, perforated French drain type thing, or a variety of methods we try to use to try to prevent the clogging there. But the basins are meant to collect sediment, and they're going to often, over time, they're going to have significant sediment buildup. So surface withdrawal from permanent detention or retention basins, again, releases that cleaner water from near the surface and allows more time for pollutants to settle. And so, does it make sense to do this during construction, but then use an orifice at the bottom of the pond for post-construction? They've been very effective for construction basins, so it just makes common sense to let's now consider that for permanent use as well. To kind of go example this, we're going to show 2 case studies. Now, both of these are projects that I've been involved with over the past really 10 years. And so 2 areas where we retrofitted ponds to help with maintenance issues. So we've got one that's a former car dealership, Simpsonville Chevrolet in Simpsonville, South Carolina, and one is an apartment complex in Charlotte, North Carolina. So first we're going to look at this former car dealership. So all this wooded area, that's the pond. So no surprise they received a notice of violation for failure to maintain the pond, as it was obviously severely overgrown and the outlet structure was not functioning properly. So after the timber was removed, and I do mean timber, it was 6 to 8 inch trees in there, we had a pond that was holding water, and it's typical in this area to have dry ponds. And so we couldn't figure out why it was holding water because you didn't see any kind of low flow outlet in there. So it was determined there was about 6 feet of mud and debris and there was a 2-inch outlet at the bottom of this basin that evidently had clogged many, many years ago, and debris just kept building up over time. So due to the size of the pond and the steep banks, it's about a 3/4 of an acre pond. Side slopes are about 1.5 to 1, so getting equipment in and out of the pond is very challenging. We had some initial estimates to clean the pond out that were $60,000 to $75,000, and this was back in 2013. So we worked with the owner. We redesigned the basin, and we designed it to allow all that muck and debris to remain in and modify the outlet structure to still meet regulatory requirements. This pond is located in Greenville County as the MS4, and they were requiring that we maintain that 2-inch low flow discharge rate as part of the original design. But we wanted to do that in a way that would not clog as easily as it did the first time. So, not having to remove the sediment buildup, we had a savings of over about $50,000 in the cleanup of this pond. So what we did is we installed a skimmer. So we used a skimmer with a 5-inch orifice. And we had to get this approved as a pilot project because at that time, skimmers were not allowed to be part of the permanent outlet structure in the county. But that 5-inch orifice with very little head on it gave a flow very close to the 2-inch low flow orifice before. So the other orifices in the outlet structure were modified. So you can see here, we closed in these orifices. We put in some new ones here, kept the top of the riser structure. So it's hard to tell here, but that riser is about 12 feet tall, and there's another 6 feet of riser that's below what is now the bottom of the pond that was, from all the muck and debris that had built up over there. So because it was a pilot project, we had to monitor it for the first 12 months of the skimmer being in place to ensure it was working properly. So these are some different photos from different time during those first 12 months, just to make sure that it was still functioning as designed. Because again, this was first time a skimmer had been allowed to go into a pond permanently, at least in this area. So about a year later, in August of 2014, the owner then was maintaining the pond. They had gone in and cut the sides and the banks and not pulled out all the debris. So basically let it all fall to the bottom. Well, we had a 5-inch rain in less than 8 hours, and it filled the pond up entirely and washed all that muck and debris down to the bottom of the pond. But as you can see, the skimmer sitting there, even with all that debris in the basin, the skimmer still drained the pond down. And if it had become clogged, you could at least get it's got a rope here. It's hard to see in the picture, but tug on the rope and get the skimmer to the side to be able to unclog it. Much safer to do so than if you had to get in and say, if that was a 2-inch orifice and this is 8 to 10 feet of water, try to get to that orifice to get it unclogged. It would have been a very dangerous situation. So we've now been using this pond, and this kind of tells you how it's filled up, as our area for research and development. So we've done a lot of prototyping for ideas with improvements to the skimmer and also adding filtration or filter fabric to the skimmer. So this is one of the early prototypes we worked. We put a filter around the skimmer to see if we could kind of create something here that would provide even higher water quality. Picture to the left is really typical. This pond is in an area that has heavily commercially developed, but very few other stormwater management facilities. So it receives about 30 to 40 acres of runoff, and it all comes to this basin. It has a lot of trash and debris in it, as you can see from this. So it requires some maintenance pretty routinely. But the skimmers definitely helped to keep it from clogging. And so the modification of that pond resulted in a savings of about $50,000 in maintenance expense. Skimmers function very well as a low flow water quality outlet, and it's been much less prone to clog and easy to access for maintenance. As I said earlier, we continue to use this site as our research and development for the filter concept. So the other case study, this one is Providence Park Apartments in Charlotte, North Carolina. So you can see here in this aerial, this was the actual pond itself. It's intentionally in a very natural area, but it also received a notice of violation in 2012. We actually received just a notice that it would be inspected for compliance. And the owner contacted us because the pond was severely overgrown and the outlet structure was not functioning properly, and asked us to come in and help repair the pond and get it ready for that inspection so they would not get a notice of violation. So went to the site, and the existing pond was a head wall with a pipe through it. And so this was I think a 10-inch pipe here. But you can see when we got there, mud was actually all the way to the top of this head wall. So it's actually pretty difficult to even find this, but we cleaned it out, got all the mud cleaned out. It's got a emergency spillway, big concrete dam, emergency spillway, but it also has a live stream running through it. So it basically maintains a small flow, trickleable flow pretty much all the time. Um, so the property owner also wanted to try to obtain a stormwater utility fee credit to help offset the maintenance work and reduce their costs going forward. So initial work involved removing all the built up mud and debris. And from the existing outlet, we reduced that outlet to a 6-inch outlet, and we obtained a 45% fee credit for them at the time. However, with all the natural debris there, that didn't work very well. So every time it would rain, that outlet would get clogged up. And so even though we had this nice riprap, berm around it, water would come over that and just put all the roots and limbs and rocks and leaves in there. And occasionally it would really clog up and hold water for days, if not weeks, and it was nearly impossible to keep the outlet flowing. And the depth of the pond made it very difficult to clear the obstructions when clogged. This water is probably 6 feet deep or so, very difficult to get to the head wall and clear it out. So we suggested that a skimmer be installed to help limit the clogging. However, the City of Charlotte Stormwater Manual specifically did not allow the use of skimmers for permanent use. So we met with the city to review the use of a skimmer. This one particularly is made of HDPE rather than PVC, and they agreed to allow it for permanent use on the condition that we provide annual monitoring for them. So we redesigned the pond. We designed the pond to include a riser structure instead of just the pipe, added the skimmer. And when in doing so, we also designed this on purpose to maximize their stormwater fee credit. So the new design resulted in a 95% fee credit, which for this site was a savings in their stormwater fees of nearly $25,000 per year. So this is once the riser was put in and the skimmer put in place. You can see we kind of dug out an area here for some sediment accumulation over time. But the cost to clean out the pond, design the permit modifications, construct the new outlet, and do all the final certifications was about $50,000 in total. And so the fee credit savings of $25,000 offset that cost within 2 years and has resulted in much less maintenance needed to keep the pond functioning properly. So there have been some few issues over time. We have to, tweak things here and there, but overall it's functioned extremely well with much less maintenance being required. The pond continues to be monitored on an annual basis, continues to function with the skimmer in place. In August of 21, we replaced the skimmer. So we did a new skimmer design back in 2020 and decided to replace the skimmer in this pond just as a prototype so we could kind of keep an eye on it. And then in 2023, because there was so much natural debris in there, they were still having to go down pretty much after each rain and kind of shake the skimmer, get it unclogged. So we installed a guard around it to help even more with the debris guard and keep the skimmer there for less maintenance. So also in 2023, they had to do some maintenance. So remember, this riser structure was put in place in 2014. So between 2014 and April 2023, there's about 3 feet of sediment built up that had to be removed because it accumulated over that 9 years. Now, that's exactly what detention ponds are supposed to do, right? Capturing all that silt and debris, sediment in the pond kept it from going downstream and impacting the waters downstream. So the riser structure and skimmer setup here showed to be very effective in capturing the sediment that was coming to the pond. So normally I do a little poll here, and since I didn't set up the Zoom, I don't have poll ability, but ask the audience, have you ever considered using a skimmer permanently? And if you would, either through chat or if you want to unmute, say yes or no. If you have any comments on that, feel free. But the follow-up to that is, if not, now that you're aware of the benefits, would you consider that? So we'll look at kind of some flaws with the traditional method of doing water quality. So extended detention for water quality is kind of what I see most often, either in dry ponds or wet ponds, using extended detention and a low flow orifice. So, the basin is designed to capture pollutants by holding runoff for an extended time, which is intended to allow for settlement. So the whole idea is hold the water in the basin, allow it to pond there, hopefully keep the water in there long enough so that the sediment particles can settle out. So if you have a basins that rely on settling time, they provide very little treatment for the smaller storm events. So, if you've got very little ponding or holding time and your whole method is based on settlement time, then if you have a small storm, let's say you get a quarter inch of rain or half inch of rain over 8 or 10 hours, right? It's going to be really tough to have much settlement in there because you have so limited ponding or holding time with that. Also one of the issues with this is the volume-based design results in larger pond sizes, and we're going to show that here in a little bit as well, about how much bigger the ponds have to be due to that first flush methodology.
Looks like you have some responses in the chat from your
Yep,
poll.
I see that. So we've got a lot of no's that thought they were temporary. One yes. One about winter conditions. I agree with you on the winter conditions. You've got to either allow for take in or take out, or what we often see is putting in a perforated riser with a valve on it. And so if you have frozen conditions, you can open that valve and allow the water to go through the riser for that limited time. But it's not a perfect solution for everywhere. And certainly if you have a lot of ice, you have to consider it. So. All right, so what are some benefits to filtration instead of settling? So let's think about it, ways to provide water quality. You can either let the sediment settle, or you can use some sort of a filter or some way to take the sediment out of the water before it gets discharged. So number one, ponds provide a large containment volume to reduce the maintenance frequency and treat the larger drainage areas. So if you're filtering out, but you're using that filter to keep the sediment in the pond, you've got a pretty big volume of sediment that you can hold there, kind of like we just showed there on that Providence Park pond. Also, there's an excellent potential to retrofit older basins that did not include water quality benefits in the design if your peak flow rate can be maintained. So I'm sure many of you are doing redevelopment. You go into the shopping center and it's 30 years old and it's time to redo something, right? Tear down one building, put in something new, change a parking lot, whatever it may be. And often we're required to provide water quality. And there may be a detention pond there that was just quantity based, but no quality. And so if you try to use that traditional first flush method and hold that first flush volume over for an extended period of time, you don't have enough volume. However, if you can use a filter and maintain that flow rate, that's an excellent way to retrofit that pond and really a very cost-effective way to provide water quality for the entire area draining to the pond. Also, filters and ponds are relatively easy to access and maintain, especially if you compare it to systems that use underground vaults or require confined space entry. So what we see sometimes is either before the pond or in some cases after the pond, using vault systems to retrofit and provide water quality, or if the pond in itself, if it's a dry pond, is not sufficient to meet your water quality requirements, there's usually an add-on of some other device. And often those devices are in vaults, so there's limited capacity for sediment storage. So some of the other benefits to filtration versus sediment is the peak rate of discharge can be based on the filter treatment flow rate up to that first quantity storm event, which results in smaller pond volumes. So typically, when we're designing these ponds, there is like a 2-year storm is probably the norm. Some places require a 1-year storm as the smallest that you got to look at quantity controls for. And so your filter can be, if your filter can handle that rate, you can discharge at that rate up to that event. The other benefit, or one other benefit, is the filter treats 100% of runoff from the storms up to the peak rate of the filter, including the very small storms with minimal ponding. So if you're using filtration and you had that really small storm event, that small storm still has to go through the filter to be discharged. So it's now being treated, and typically much more effectively, than it would be if we were relying on settlement and ponding to do so. Last item is the filtration media can be customized to target specific pollutants of concern. It's, hydrocarbons are a concern in many areas. Pretty easy to add a media that can absorb hydrocarbons. Metals may be, phosphorus, nitrogen. There are a variety of other materials out there that can be added to your filter and provide a real benefit to targeting some pollutants that just settlement by itself may be harder to take out. So, we've talked about filtration. Now let's add a skimmer to a filter. So what would be the benefits to using the skimmers with filtration? So one, the skimmer can be sized to control that peak rate for the lower storm events. So depending on the size of your site, you may be able to size the skimmer to handle that 2-year flow. So now the skimmer is your low flow orifice, and also it's handling up to your 2-year storm event. I apologize, I was fighting a little bit of a cold today, so trying to minimize the coughing. So the skimmer increases your filter efficiency by withdrawing water from the surface where the water is cleaner. So if your filter were just stuck down here at the bottom, it's going to get the highest concentration of sediment to it, right? But if your filter can float up and down with the water level and just have to treat that water that's closer to the surface, it's not having to work as hard. There's less concentration there, so your filter is going to work better, last longer, have a higher efficiency rate. And then lastly, the skimmer is easy to access or pull to the side of the pond, so you can get to that filter and get to the skimmer for maintenance and changing of the filters. So there's some challenges to using skimmers with filtration. Number one, filters are prone to clog over time and will require maintenance and periodic cleaning or changing. We all recognize maintenance is a huge issue in stormwater management, whether it's a pond, whether it's a catch basin filter, or any other type of device, and even an LID, a sand filter, bioretention area, any of those things are going to require maintenance over time. Filters may require a little more maintenance than some of the other products, but they're maybe also less costly to do so and easier to get to. Skimmer's got to be durable and last more than a few years to be suitable for permanent use. We recommend HDPE versus PVC products for this. There may be some other products that are more durable, designed for permanent use, but you got to make sure it's going to be something that's going to hold up for quite a while. You need something that's not going to degrade in UV over 2 to 3 years. And here also, we've had a couple of comments about frozen conditions. You're going to need an alternate drain during the frozen conditions, or it just may not be suitable. If you're in an area that, has several months out of the year, that's going to have frozen conditions, then this just may not be the right tool for that situation. And then the biggest challenge that we see right now is there are no established standards for basis of design and permitting based upon a combination of pond and filtration. So Rebecca was kind enough to share our attendee list on Friday, and just kind of skimming through, looked like we had a lot of city, county, kind of regulatory folks that had signed up for this. So for those of you that are on here, love to hear your thoughts on how we manage the permitting process and how you can incorporate ideas that are maybe a little outside of the mainstream, but also can be very effective so that those tools can be allowed to be used in your area. So currently that I'm aware of, there are 2 widely recognized testing protocols. So you've got the Washington Tape program and the NJCAT certification program. So the Washington Tape program, it is a field version. So there you actually have to find sites, have to go through a year or 2 of storms, have to have those monitored and sampled and lab tested to show the certificate, what the results. Very effective. It's going to give you real world test data, also very expensive and very time consuming. You also have the NJCAT certification program. So the NJCAT has established protocols and standards for testing, and a lab has to be certified that meets their certification. And that lab can then test your product, and then you send the results of that test into NJCAT, and they'll verify your device and say, okay, you're now certified to meet a certain percentage TSS removal. And TSS is the main one. What you may not be aware of is ASTM now has standards for sediment retention and sediment devices and stormwater products. So ASTM is is still in development of many of these. Some of them have not been finalized yet, and others are coming. And somebody asked if there's a speaker voice technical problem. I hope not, but if other people are having trouble hearing me, please let me know.
So far, it
But
sounds good.
okay. So again, ASTM standards have come out, and some of you may also be familiar with STEP, and I forget what STEP's stormwater. Anyway, it's a national stormwater program. I can't even remember what STEP stands for, STEPP. But all the STEP program protocols are going to be based on ASTM standards. So ASTM's long been recognized as having a very rigorous process for establishing their standards, very trustworthy program, to meet, and so a good basis to base your designs on. So we've gone through prototyping of trying to come up with how to do a filter around a skimmer for about 5 years now. I'll go through just a couple of just kind of show you the process we went through. So we went through this one. It had kind of strips here of non-woven geotex on the outside, and it had some coir fabric on the inside. We did another layer of fabric in there, just trying to make sure we filtered water thoroughly. Had a flow rate of about 140 to 150 gallons per minute per square foot, trying to keep up with the skimmer. What we found out is the flow rates generally kept up with the skimmer, and it provided good filtration. In this case, we had an open bottom for it too. So the thought was that you would filter what's near the surface, and if it was more than a couple of feet below the surface, we just let gravity do its job. But what we found over time was that this just wasn't big enough to keep up with the flow rate of the skimmer, especially on some of the larger skimmers. We even put dye in the test tank to kind of see, hey, is water getting pulled in? Because you obviously got a pipe leaving. Is water getting pulled in through that opening or pulled in through the bottom? Saw very little of that. And then this picture on the right is the outflow. We had a weir tank set up to test the flow rates, and really clear water was coming into this. And we were pulling water from a farm pond, so it wasn't really dirty either. But I can say that the water here was much cleaner than what we were pumping into it. Again, kind of check the fabric. We had a lot of just, algae and kind of general debris in the farm pond getting pumped in. What we found is the coir fabric did not seem to blind off or trap too much of that, so it showed pretty good filtration. But we decided in the end to go with a different product. So we did a two-stage filter back in March of 21. So the outer stage is this was sort of a turbidity curtain. It's got just a polyethylene screen in it. It's a Mirify fabric. And then the inner was a non-woven material called Adsorbate, which was also, in addition to TSS, would absorb hydrocarbons as well. And this is back in that same pond we showed earlier as one of our examples that we've been using for our research and development. So we had the prototype in the pond for over 24 months. We wanted to make sure it would have, last long enough that would be worthy of having on a site. If it's going to fall apart or clog up in 6 months, it's not going to work. So again, the area flowing in this pond is highly developed with few other stormwater management. So as you can see from these photos, a large volume of trash and debris enters this pond, making it a real challenge to keep the outflow clean there. We set up a time-lapse camera at the pond, and so this was taken in July of 21. So you can see here, this is on July 7th that it just started to rain. By the morning of July 8th, so about 12 hours later, the pond was full. You can see the skimmer here is all the way up to the top of the riser. Later that morning, the pond's now starting to come down. That evening, it finally started raining. It kind of rained on and off most of the day of the 8th. And then by the morning of the 9th, you can see we've made some progress to drain it down. And then by the 10th, it's pretty much already drained. So if you recall, the design of this pond was based on that first flush method. So the intent was to hold a 1-inch runoff volume for at least 24 hours. And so this, time lapse shows that we're holding it for about 48 hours to drain that full volume down. And the volume all the way up to these orifices is more than that 1 inch. That's probably more of a, full 2-year storm. So it's probably 3 or 4 inches of runoff from the area coming down. So, but a good example of skimmers working, draining the basin slowly, allowing the sediment and other pollutant particles to settle out. So one of the other things we noticed during this time was vegetation started to grow in the inner non-woven filter. And so at first we're like, that's not a good thing. But then we started thinking, hey, if we put the right seeds in this thing, and it's kind of in that non-woven filter fabric, it just catches stuff. Maybe there's some potential for nutrient removal. Now, we also recognize nutrient removal sometimes takes a lot of vegetation for any kind of uptake of phosphorus or nitrogen. So maybe not. We'll kind of test that in the future. But it was just kind of an interesting observation that happened. And then over the winter, the vegetation died. So we kind of went in and trimmed it up, cleaned it up a little bit, but we didn't change out the filters. We wanted to keep those in place, just see how long they would last, make sure they'd last at least 2 years. So again, we may look in the future at, potential to target certain pollutants with certain vegetation, if we can get enough of that, especially on the larger filters to go in. It did notice in July of that year, the vegetation returned. And so, it could be something worthwhile, although I'm not a huge on the chemistry or, for the phosphorus and nitrogen. So if you only had the vegetation growing during the summer, spring and summer months, would that still be a benefit or not if it died off during the winter? So anyway, we continue to monitor this. You can see in this picture on the right, the turbidity of the water outside the filter is certainly higher than in. So you can see there's definitely a color change between there. And then left picture here is the actual outlet of this pond. And so that's actually flowing fairly clean water coming out of there. So the field testing showed that it, seemed to be working well. So we decided to take the next step and go to third-party testing to confirm TSS removal, and we had TRI Environmental do that testing for us. So when we had TRI do the testing, we wanted to do this in a way that would give us kind of the worst case scenario. So the ASTM requirement or standard requires 2 versions of the skimmer with the filter to be tested. And there had to be a double the flow rate between one and the next. So one was tested at I think it's around 30 gallon per minute flow rate, and the other one had like 140 gallon per minute flow rate. So pretty different flow rates, with that. The other thing we did is we had the sediment laden water enter right at the filter. So, with your typical detention basin, you're going to have a forebay. You're going to try to maximize the length between your inlet and your outlet to give as much distance as you can and much settling time. Well, we said, it's going to be really hard if we incorporate all that to see how much of a benefit the forebay was, how much was the travel distance, how much is the filter, how much is surface withdrawal. So what we did is we set this test up to have the water come in right at the filter and simulate a dry basin. We made the assumption that a dry basin is going to not perform as well as a wet basin in most cases. So we wanted to kind of do the worst case scenario. And again, we did this to the ASTM standard of C1746, which is the standard test method for sediment retention devices. We've had some questions in the past about soil gradation. All that's in the test. I can't include that in this presentation, but if anybody has any questions of that, we're happy to provide the test results and all that backup detail with it. So again, we had to do two versions of Skimmer there. Both versions achieved greater than 90% TSS removal efficiency. So one got 92%, one got 96%. TRI felt comfortable saying 90% was a reasonable for the skimmers. And based on these test results, we can scale the size of the filters for other skimmer sizes as well that have higher flow rates than what the test tank could handle. And so this is kind of just a representation of how that works. So you've got an outer layer for debris and large particle removal. It's a polyethylene fabric. You've got an inner layer for the smaller particles. Again, that's the non-woven fabric by Adsorbit. The version we use actually has an antimicrobial treatment as well. And then when you put those together with the skimmer, with the surface withdrawal, that system achieved the 90% TSS removal rate. So now I want to kind of talk about advanced skimmer modeling, so a filtration-based water quality, and how would that compare to your traditional first flush model? So we're going to go through a sample site here. So, the first flush model, if you're not familiar with that, typically you take a certain volume. In our area, it's 1 inch of runoff over your area, and you release that over 24 to 48 hours. Versus a filtration-based model, which is just based on the flow rate of the filter to be able to handle that flow and treatment up to whatever your first quantity storm is. So our sample site, let's just assume we have a 5 acres. We've got a pre-development condition, curve number 55 for a wooded, and then post-development is going to commercial. So we're going to take 5 acre, natural wooded area. We're going to convert it to a shopping center. Got a question about Georgia uses turbidity as criteria rather than TSS. I am familiar with turbidity as a requirement during construction in Georgia. I'm not familiar if Georgia has that requirement post-construction. And what I would say is the skimmers do a little bit of help with turbidity during construction, not much. And you're gonna, you're really gonna need flocculants or some other way to take out turbidity. So anyway, again, kind of back to our sample here. Post-development, again, we're going to a shopping center, 92. So the first thing we're going to do is we're going to come up with what our pre-development flow rates are. So based upon a 5 acre site, I just assumed a time of concentration of 48 minutes, and we said our 2-year flow is going to be 0.72 CFS. Oops, back up. 10-year, 3, 25, so on. So we're really just going to focus on this 2-year and lower flow rate for this example. So the next thing we're going to do is we're going to look at our water quality volume and our post-development flow rates. So based upon that 5 acre commercial site, I assumed a time of concentration of 10 minutes, and we want to calculate the water quality event. And so what I did is in this area, we just assumed a 1-inch runoff was what's required. And so I went through a trial and error and came up with a 1.73-inch 24-hour storm that would generate that 18,150 cubic foot volume of runoff. So again, even though it's the curve number 92, takes more than 1 inch of rain to generate a 1-inch runoff volume, almost 2 inches of rain in this case. And again, it is important to note the water quality volume does vary from state to state. And so it's 1 inch to 1.5 inches is what's typical, is what I'm seeing in most states as far as requirements. But again, in this case, our water quality flow rate, this is just post-development before any pond or anything, 7.2 CFS, and then the 2-year was jumped up from 0.72 to 19.72 CFS. So in the traditional first flush method, most engineers I've talked to have a spreadsheet that's somewhat similar to this, and they will calculate the size orifice required to drain that volume within whatever time. So again, in this case, we got 5 acres. So we got 270,800 square feet of area. That 1 inch is going to generate 18,150 cubic feet of volume. We're going to base that on a 24-hour time frame and come up with a flow rate of 0.21 cubic feet per second. And there's some head calculations in that to come up with the required orifice size. Let the spreadsheet do its work, and we come out with a 0.21 feet or 2.6-inch orifice. And one thing to point out about this is this method assumes that this water quality volume kind of poof magically appears in the pond, right? Obviously, we know there's a hydrograph. It's coming in at a certain rate and going out at a certain rate. But when we calculate this orifice size, we're assuming it all gets there instantaneously, and then we drain that down over 24 hours, which we know is not really how it's going to happen. But anyway, that's what we do. And so kind of came up with this pond design, and we said, okay, this volume of 18,150 cubic feet, bottom of pond's 110, so I got to 113. So I got about a 3-foot depth in this hypothetical pond to hold that volume. Put in a 3-inch orifice above that and another 8-inch orifice above that, and then the top of the track. So that's my 2-year storm control, my 10-year storm control, then my 25 or 100-year storm control. And we'll assume we have a 3-inch orifice down here instead of 2.6, just so it's easy for the contractor to put in correct size. So when we do that, run through our hydrology program, our water quality flow rate going out now is 0.25 CFS. And as we note here, we're not using that 18,150 cubic feet. We're really only using just under 10,700 cubic feet. So about 2/3 or so, just under 2/3 of the volume that's required is actually being used for that hydrograph. Now, the rest of this volume, typically you're not allowed to put any orifices in there. So, we've got an elevation of 113, where our peak elevation here is really 12.51. So we've got about a half a foot in the pond that's basically excess storage that's going to be used. It'll help with our larger storm events, but it's really not it's being used to its full potential. And our 2-year storm in this case is a 0.81 CFS. Our pre was 0.72. I fully realize that there are certain areas that the reviewer is going to say it has to be 0.72 and no higher. Other areas may let you get away with a little slight increase in that 2-year storm as long as you're maintaining the 10 and the 25. But anyway, that's MS4 specific. And so if you run these, just kind of a summary table, but the thing here to point out, these are the storage amounts required under this traditional pond analysis, and we will use those a little bit later. So the next thing we do is we're going to look at a skimmer with a filter design. And so the first thing we want to do is we want to select the skimmer that's going to be close to that 2-year storm rate. So in this case, our 2-year storm flow is 0.72. And so we go over here and pick out our 6-inch skimmer with a 6-inch orifice flows at 0.78. And so that's going to be kind of our first one we're going to try with this model and see how it works out there. So this is the detail for the filter. A couple things to point out about it is you've got a L1 and L2 lengths. So you got different different lengths here. The reason we have that is you typically don't want the barrel between your riser structure and your skimmer to be more than 20 feet. It would typically require you putting 2 pipes together. And so we want to try to keep that to 1, just because we start joining pipes, you're going to create some issues in the field. And so because of that, we don't want this length from the skimmer to the filter to be more than about 10 feet. Because the idea is that the filter itself or the skimmer itself will rise up at about a 45-degree angle. And when it does so, it's going to get closer to the riser structure. So we don't want the filter hitting up against the riser. So because of that, the L1 gets pretty long. So some of these larger skimmers have pretty high flow rates. The Max 8 has about a 1.8 CFS. And so that L1 gets all the way out to 46 feet. And the L2, the max is 16. So no more than 8 feet from the center of the filter in this direction, but 23 feet each side of the skimmer the other direction. The other thing to point out about the filters is they're 3 feet deep, so they hang 3 feet, but they're open on the bottom. Again, we're going to let gravity do the work there. So anything in the top 3 feet is going to have to go through the filter to get discharged. Anything below 3 feet, there's not going to be enough force in the flow to pull that sediment particle up to get discharged by the skimmer. And then this is your typical kind of basin, just kind of show how it would be situated there. You'll have a 4-bay, other information you have on your detail. So if we look at the hydrology model now with the filter, we'll see our water quality volume is now being released at 0.7 CFS, and we're only using 7,600 cubic feet of that volume. Okay. Also, our 2-year storm rate is being released at 0.78 CFS. And so in our outlet structure, we don't have a low flow orifice. We have the 6-inch skimmer there, and we don't have that 3-inch orifice we used to have. We'll go up to the 8-inch, it's going to control the 10-year storm above that 2-year storm rate. So our 8-inch orifice is set at about 114.8. Our peak elevation for our 2 years, 14.68. So point being that you're releasing that water quality volume about 3 times as fast as you did under your first flush method, and you're using a lot less volume in the pond to do that. And your 2-year storm is a little bit lower than it was before. So then if you compare the storage required for each storm event, you'll see that they're less under the filter-based model than they were under traditional model. And kind of easier to point out in percentages. So you're looking at saving about 30% of your storage for your water quality event, and 14% on your 2-year, and about 12% on the other storms. So your reduction in your total pond volume is about 15 to 20% of your total pond volume is being reduced, and you're treating to that higher rate. So I know going pretty quick today, so and this isn't really intended to be promotion, but we have a design series on our website that kind of goes back through the details of how to incorporate the skimmer into like hydroflow and other things. So just making you aware of that if you need to go find it. So again, we're going to work on future R&D to conduct, for the filter media to see about removing metals, hydrocarbons, other pollutants. I do want to point out we're actively looking for test sites. So one of our next objectives is to get the product approved in North Carolina. I don't know if we have any folks from North Carolina on the call with us today. I'm sure we do with the amount of people on, but North Carolina has a procedure for proprietary devices, and it requires a minimum of 2 and preferred up to 4 test sites. So if you're on the call today and you've got a site that you'd like to consider this on and maybe want to be a test site for us, we'd love to talk to you about that. And again, this is the commercial version of the filter. So this goes back to that pond. So it just kind of gives you a better view of what that pond looks like, about how steep the side slopes are, how much debris is in it. But it is a dry pond. The skimmer does basically drain it down over time, and it continues to work well. And we've got a time-lapse camera set up to make sure it's monitored. So in summary here, skimmers are less prone to clog than other orifices that are located at the bottom of the pond, and often require less maintenance to keep the pond functioning properly. Asterisk there for frozen conditions. Skimmers can be very effective to retrofit existing basins, reduce that maintenance, provide enhanced water quality, like we showed in the 2 case studies. It's a good way to reduce the clogging that those small orifices tend to experience at the bottom of the pond. And the surface withdrawal releases cleaner water from the basin for enhanced water quality. And this is just with the skimmer itself, no filter involved. If you add the filter, use of the skimmer with the filter has been tested, confirmed 90% TSS removal efficiency, again, per that ASTM standard. The skimmer with the filter treats more of the annual rainfall, including those very small storm events, and up to the largest event that's managed by the skimmer. So if you're able to design your site to let the skimmer handle your 2-year storm, you're now treating much more of the annual rainfall, probably over 90% of the annual rainfall. If you get up to a 2-year storm and below, you're going to get, vast majority of your rain during the year is going to get treated to that 90% level. And then finally, the filtration model reduces the pond size by 15 to 20% over the traditional first flush method. So, for all the consultants on here, I have had one consultant tell me that the client wanted a larger pond because they needed dirt on site, so they were digging out to create dirt. But pretty much everyone else has said, hey, if we can get to a smaller pond, our client would be very happy. So that tends to be the case. And that's our presentation for today. Got a few minutes for questions. So if anybody has a question they want to put in chat or just unmute and ask, I'd be happy to answer that. Also has our general email, info@rymarwaterworks.com, if you have any other information you'd like to get from us. And you can scan the QR code as well to take you to our website. Those that have mentioned turbidity, I'm curious. In Georgia, do they look at turbidity post construction? I know they do during construction, but I was not aware they looked at turbidity post construction. And if anybody else has any other questions, be happy to answer them.
Fantastic. And while we're waiting for any questions in the next couple of minutes, if you have not signed up for any of the other workshops, we have a great line of workshops. There's one starting in just a couple of minutes about holistic on-site wastewater and stormwater recycling. Then we have one coming from Florida about their stormwater regulations and requirements. It's always fun to hear what different states are doing for stormwater. So even if you're not in Florida, that's an interesting one to attend. And then to end the day today, we have a RESTL application for notice of termination, and that is at 3 p.m. Pacific time. And there's a whole bunch more workshops the rest of the week, so head over to stormwaterawareness.org and you can register to attend any of those or watch any of the ones that you missed. It looks like we have one comment. Do you see that in the chat, Jamie?
Yeah, that's the the question on turbidity. Yeah, that's basically during construction until the site has achieved final stabilization, which I do understand is required in Georgia for turbidity management. So, Rebecca, I just want to thank you again for allowing us to be a part. I think it's a great thing for Stormwater Awareness Week to come out and make all these available to everyone, especially at no cost. And appreciate everybody joining us today.
Yeah, thank you, everyone. Thank you, Jamie, and we hope to see you at another workshop.